Imagine you're looking at a massive digital maritime map of the globe. You see the continents outlined in crisp borders, and you've got the world's shipping lanes tracing across the blue water like these thin, glowing arteries.
Right, the typical global logistics view.
Exactly. Now imagine a digital brush suddenly paints this massive, solid red zone right across the entire North Atlantic. We're talking a boundary that wraps all the way around the huge landmass of Greenland, catches Iceland, pulls in the Faroe Islands, and then sweeps down past the UK and Ireland.
And it keeps going, right, down the western coast of France and Spain.
Yeah, right down past Portugal. It is a massive chunk of the ocean.
It really is a staggering amount of maritime real estate to just cordon off. I mean, when you look at the sheer volume of global trade passing through that specific corridor from, North American grain to manufactured goods out of Northern Europe, drawing a new boundary there alters the logistics of thousands of vessels instantly.
And that red zone isn't a hypothetical projection anymore. That is the new reality for global shipping. So today we're taking a deep dive into a really fascinating stack of sources you sent us to figure out what actually happened at the recent MEPC 84 summit in London.
Yeah, we've got some great material to work through.
We do. We're looking at a highly detailed professional maritime briefing from a publication called the DeepDraft. It's written by a serving master mariner, Captain Raghu Sharma, and it's dated just a few days ago on May 14th, 2026.
Which gives it a very, very current perspective.
Exactly. And along with his analysis, we have a series of regulatory tables, plus some incredibly vivid photographs from the field. There are shots of a ship's engine room, a crew member doing fuel sampling out on the deck, and this beautiful, but honestly highly intimidating shot of sea ice off the coast of Greenland.
Oh, that ice photo really sets the stakes. Our mission today is to cut through the headline-grabbing political gridlock of that London summit and look at the actual engine room reality. Because what seems on paper like a simple, map update is actually sending a massive engineering, commercial, and operational shockwave through the entire global supply chain.
Okay, let's unpack this by setting a baseline with what actually occurred at the 84th session of the IMO's Marine Environment Protection Committee, the MEPC, which met in London from April 27 to May 1st, 2026.
Right.
Mainstream coverage focused really heavily on the failure to finalize the IMO Net-Zero Framework for carbon emissions. But Captain Sharma's briefing argues that for the ships actually out there on the water, the concrete operational outcome was the creation of that giant red zone on our imaginary map.
The North-East Atlantic Emission Control Area, or ECA. Distinguishing between those two completely distinct outcomes, the carbon framework that stalled and the ECA that sailed through, provides this masterclass in how international shipping actually operates. You really have this clash between political aspiration and, operational physics.
Yeah, and Captain Sharma makes a highly critical point about the narrative surrounding the industry. He pushes back against the idea of shipping as the, quote, convenient villain of the climate debate.
Which is a very common framing in mainstream media.
It is, yeah. But his argument is impartially presented here, that you can't just mandate carbon away when the physical infrastructure for alternative fuels simply isn't ready on a global scale.
What's fascinating here is the underlying principle he's highlighting, which is regulatory realism. Decarbonizing a massive cargo ship isn't merely a matter of legislative will.
Right, you can't just wish it into existence.
Exactly. If a regulator demands a ship run on zero carbon fuels, like methanol or ammonia or hydrogen, that vessel requires entirely new engine blocks. It requires fundamentally different types of cryogenic or high-pressure storage tanks.
Because it's a completely different chemical reality.
Right. And most importantly, it requires a global bunkering infrastructure so the ship can actually refuel, whether it's sitting in a massive hub like Rotterdam or discharging cargo at a remote port in the developing world.
And the briefing notes that some of those new fuels come with serious safety risks that haven't been fully mitigated yet. You're looking at needing entirely new class approvals, completely overhauled crew training, insurance acceptance, and commercial contracts that can actually absorb the premium cost of these experimental fuels.
The challenge just becomes exponential when you look at the different types of maritime trade. I mean, mandating a new fuel works reasonably well if you have a passenger ferry operating on a fixed, predictable route between two modern ports with dedicated infrastructure.
Sure, because you know exactly where you're stopping every day.
Exactly. But a massive portion of the global fleet operates on tramp trades.
Tramp trades.
Yeah, those are ships that just go wherever the cargo dictates, changing destinations on demand based on commodity markets. For those vessels, relying on non-existent infrastructure is a literal logistical impossibility right now.
Wow.
And that lack of physical readiness is precisely why the Net Zero Framework was deferred to December 2026. The political gridlock reflects an operational reality. The pathway to zero carbon is just still under construction.
Which perfectly explains why the emission control area passed without that same gridlock. The machinery and the rules to enforce the ECA already exist, right? The industry knows how to execute it.
Precisely.
So let's look at the mechanics of this regulation based on the comparison tables in the briefing. Outside of this new North-East Atlantic ECA, the global sulfur limit for marine fuel is 0.50%. Inside the new ECA boundary, the limit drops down to 0.10%.
Right, a significant drop.
But MEPC 84 didn't invent those numbers. The 0.10% rule has been enforced for years in established areas like the North Sea and the Baltic Sea.
Yep, they're used to those metrics.
So on the surface, to me, this looks essentially like a highway patrol expanding a 55-mile-per-hour speed zone. You're enforcing the exact same rule, just over a much longer stretch of road, right?
Well, let's adjust that highway analogy slightly to fit the physics of a marine engine because, changing your speed is just easing off the throttle.
Okay, fair point.
What this regulation demands is fundamentally changing the actual physical type of fuel that a massive multi-story engine is actively burning while the ship is underway in the open ocean.
Oh, wow. So instead of slowing down your car, it's more like trying to swap your car's engine from burning thick, heavy gasoline to burning ultra-thin diesel while you're actively driving down the highway at 60 miles an hour.
That captures the mechanical danger perfectly.
Yes.
The 0.10% regulation itself isn't new, but the geography of where you must perform this highly complex mechanical maneuver is vastly expanded.
That timeline is pretty strict, isn't it?
Very. The ECA enters into force on September 1st, 2027, with the actual operational requirements hitting exactly 1 year later on September 1st, 2028. So for a junior officer navigating on the bridge, the core challenge isn't memorizing a new sulfur limit. It's learning to navigate a completely new geographical map.
Because the line moved.
Right, because the moment that boundary line moves on their digital navigational chart, every engineering process in the belly of the ship has to shift with it.
And let's look at the physical reality of that shift, because those photographs from the engine room are staggering. I mean, we have an image showing this incredibly dense, chaotic maze. It's just a vertical wall of heavy gray pipes, massive bolted flanges, red hand wheels, and silver insulated lines running in literally every direction.
It's an intimidating environment to work in.
Totally. And the briefing specifically calls out something known as the tank trap, and it pairs it with the heavy weather of the North Atlantic.
So if I'm interpreting the physics here correctly, the existing low-sulfur heavy fuel oil is incredibly thick, right? It has a high viscosity, meaning it essentially has to be boiled just to be pumped through those gray pipes.
Oh, absolutely. The operational temperature for a heavy fuel oil can be around 130 degrees Celsius.
Wow, so it's boiling.
It is practically a semi-solid at room temperature. Conversely, the 0.10% compliant fuel, which is usually a marine gas oil or a clean distillate, that's thin, it's highly refined, and it operates at a much lower temperature.
Okay.
When a ship crosses into this new North-East Atlantic ECA, they aren't just doing a quick coastal hop like they might in the English Channel. The map shows a multi-day open ocean transit through that red zone.
Which means the ship has to carry vastly larger volumes of that expensive, clean 0.10% fuel just to survive the longer transit.
And here is where I assume the tank trap comes into play. If a ship doesn't have enough dedicated tanks built solely for the clean fuel, the crew has to repurpose a heavy fuel tank to carry the clean distillate.
Which is where things go very wrong.
Right, because the heavy fuel leaves behind a thick, residual high-sulfur sludge coating the walls of the tank. If you just pump the highly refined clean fuel into that tank, the clean fuel acts like a solvent. It melts the sludge, mixes with the high sulfur residue, and suddenly, the expensive legal fuel you just bought is chemically contaminated and over the 0.10% limit.
The chemistry works exactly like that. You can spend hundreds of thousands of dollars on compliant fuel, and a microscopic layer of sludge in a poorly prepared tank turns the entire batch illegal.
That is terrifying.
It is. Now, layer the environment on top of that chemistry. Looking at that photograph of the ice off Greenland, we are reminded this is not a calm harbor in the Mediterranean.
No, definitely not.
From 2028 onwards, engineering crews are going to be performing these delicate fuel changeovers in severe North Atlantic weather systems.
So you have a ship rolling and pitching violently in a storm, and down in the engine room, The chief engineer is trying to transition the fuel lines from 130-degree heavy oil to freezing cold marine gas oil. If they rush the valves, pumping cold fuel into a boiling hot engine block, I mean, the thermal shock would be catastrophic, wouldn't it?
Completely. The metal components inside the massive fuel pumps contract at different rates when they're exposed to sudden temperature drops.
Oh, so they just break.
The pumps will literally warp, grind, and seize up, and if the fuel pump seizes, you lose your main engine.
Oh, man.
Yeah, losing propulsion in the middle of a North Atlantic winter storm is a worst-case scenario. It threatens the life of the crew and the survival of the vessel.
But on the flip side, if the chief engineer takes it too slowly to protect the engine.
Then the ship crosses the geographic boundary line on the map before the clean fuel has fully flushed the heavy fuel out of the miles of piping. The smokestack is still emitting sulfur above the 0.10% limit when they enter the ECA. That constitutes a strict compliance failure and a massive legal liability.
Wow, so the chief engineer is walking a microscopic tightrope between catastrophic mechanical failure and an international legal violation.
Exactly.
Okay, so that perfectly isolates the sulfur side of the equation, which is dictated by what physical liquid is actually sitting in the tanks. But Captain Sharma's briefing outlines a completely separate half to this ECA regulation involving nitrogen oxides, or NOx.
Yes, the engine rule.
Right. Specifically, the mandate for NOx Tier 3 compliance. Now, if I put on the hat of a skeptical ship owner for a moment, and I'm looking at this massive new red zone, does this mean that I owned a fleet of older cargo ships currently trading across the Atlantic? I suddenly have to dry dock them, rip out the engines, and install multi-million-dollar exhaust scrubbers by 2028 just because the IMO drew a new line on the map?
Captain Sharma specifically highlights that exact panic as one of the major key misunderstandings circulating in the industry.
So it's not true.
The answer is definitively no. Older vessels are not forced into mandatory retrofits just across the line. The critical distinction to internalize is that sulfur is a fuel use rule. It regulates what you pour into the engine.
Okay.
But NOx Tier 3 is an engine certification rule. It regulates how the engine itself is physically constructed to burn fuel.
Oh, got it. And the briefing provides 3 very specific, staggered deadlines for this NOx Tier 3 requirement. It applies to ships contracted on or after January 1st, 2027.
Right.
Or, if there is no official building contract, it applies to ships whose keels are laid after July 1st, 2027 or delivered after January 1st, 2031. Why are there 3 different dates instead of just a single line in the sand?
Because those 3 dates map the entire life cycle of a ship's berth, from paper to steel to water.
Oh, that makes sense.
The international shipbuilding supply chain moves incredibly slowly. A ship owner signs a contract today, but the shipyard might not actually cut the steel and lay the structural keel in the dry dock for another 6 months.
And then building it takes even longer.
Right. The final fitting and delivery of that vessel might take 3 more years. The regulation targets the supply chain timeline to ensure the mandate applies strictly to the future of the global fleet.
So an existing ship sailing the Atlantic today, in 2026, is safely grandfathered under whatever engine tier it was originally built to.
Exactly. The map change does not retroactively penalize the older engine. However, any new ship ordered for the European or North Atlantic trades moving forward will need to have Tier 3 capability built into its architectural design from day one.
What does that actually look like?
It usually means installing selective catalytic reduction systems, which you can essentially envision as massive, highly complex catalytic converters fitted to the ship's exhaust system to neutralize nitrogen oxide before it ever hits the atmosphere.
Okay, so knowing your older ships are grandfathered for NOx is a massive financial relief. But surviving the mechanical tightrope of the sulfur switch in the North Atlantic weather is ultimately meaningless if the vessel cannot legally prove it actually switched the fuels, right?
Compliance is everything.
Exactly, and we have 2 incredibly telling photographs in the source stack regarding this. One shows a crew member in an orange hard hat and coveralls. He's crouching next to a massive black bunker pipe on the deck, and he's turning a tiny valve that is dripping dark fuel into a clear plastic bag.
Yep, the sampling process.
Right, and the other photo is a close-up of a small, dark plastic bottle with a white label reading MARPOL Annex I sample. It's sealed shut with a white, tamper-evident plastic tag bearing the serial number 1061297.
Those two images capture the absolute, uncompromising reality of modern maritime compliance. The moment the ship's GPS crosses the boundary on the ECDIS, the electronic chart display and information system on the bridge compliance ceases to be a theoretical concept.
It gets very real very fast.
Extremely real. When a port state control inspector boards the vessel in France or the UK or Iceland, you cannot verbally debate your compliance.
You can't just point to the heavy weather and say, hey, we had a rough crossing, but I promise we switched the valves in time.
The inspector doesn't care about the weather. They care about the unbroken, verifiable paper and physical trail. Every single piece of documentation across the ship's departments must align perfectly with the vessel's digital position at sea.
So what are they looking for specifically?
They'll cross-reference the timing of the changeover recorded in the engine room logs against the passage plan drawn up on the bridge. They will demand the bunker delivery notes, the BDNs, which are the legal receipts proving exactly what chemistry of fuel you purchased from the barge.
And the bottles.
Exactly. Finally, they can confiscate those physical MARPOL samples you just described.
Wow, so that little plastic bottle with the tamper seal. The inspector can physically send that off to a laboratory.
They absolutely can.
And they can verify if the actual chemistry of the liquid matches the sulfur limits claimed on the bunker delivery note, and if it matches the logbook entries claiming when the clean fuel reached the engine.
Right. The regulation dictates a 0.10% sulfur ceiling. The vessel has to make that microscopic number physically true inside a real pressurized fuel system, dealing with real sludge, documented by real records.
Yeah, it is intense.
As Captain Sharma notes in the briefing, the master of the vessel doesn't want heroics or drama. They need a clean geographical boundary, a clean mechanical changeover, and a bulletproof record trail to hand over to the authorities.
And stepping back from the engineering deck for a second, this operational hazard triggers a massive commercial fallout too. The mechanical execution starts down in that maze of hot and cold pipes, but the financial consequences land squarely on the commercial desk.
Oh, without a doubt.
I mean, burning 0.10% marine gas oil is vastly more expensive than burning standard global 0.50% heavy fuel.
The geographic expansion of this ECA fundamentally alters the economics of the Atlantic trade. A ship will now spend days, rather than hours, burning premium-priced distillate fuel.
Which completely changes the math.
It completely rewrites the voyage estimates and bunker planning calculations, and it immediately ignites highly contentious disputes in the charter party agreements.
The charter party being the foundational contract between the ship owner who operates the vessel and the commercial charterer who is renting the vessel to move their cargo. I can see the battle lines forming instantly, like who is financially responsible for the massive premium on the clean fuel.
And the disputes go much deeper than just the fuel bill, too. If the tank wasn't cleaned properly and the fuel gets contaminated, who pays for the delay?
Right.
Did the charter's voyage orders allow the chief engineer enough time to perform a safe, slow thermal changeover before hitting the ECA boundary? If the fuel pump seizes due to thermal shock and the ship loses propulsion, the vessel goes off higher.
Meaning the owner stops getting paid while they drift and repair.
Exactly. Commercial teams cannot wait until 2028 to untangle this liability. Fleet circulars, engineering audit checklists, and the complex legal clauses within charter contracts must be rewritten today.
So an invisible line on a digital chart inevitably manifests as millions of dollars in commercial risks.
It's spot on.
So what does this all mean for you, our listener? We've traveled from a high-level geopolitical summit in London directly into the freezing pitching engine room of a cargo ship battling a North Atlantic winter.
Quite the journey.
It really is. We are looking at a maritime world defined by increasingly overlapping regulations. You have MARPOL Annex 6, these expanding ECAs, the EU emissions trading system, fuel EU maritime mandates, and carbon intensity indicators. It's a massive, incredibly dense web of compliance.
It can be overwhelming for operators.
Yeah, but the fundamental insight from the sources is that the maritime supply chain can and will adapt when the rules are mechanically clear and the physical technology is actually ready. The North-East Atlantic ECA passed and is moving forward rapidly because the compliance pathway, the 0.10% fuel, the thermal changeover procedures, the physical sample bottles, it's a known executable quantity.
The physical reality dictates the regulatory success. And this leads to a really critical question for you to consider based on the concept of regulatory realism that Captain Sharma champions.
It's that.
Well, this new ECA proves definitively that the global shipping industry is capable of executing massive, logistically terrifying operational changes when the existing infrastructure and engineering actually allow for it.
Right.
But as that deferred December 2026 deadline for the IMO Net-Zero Carbon Framework approaches, we really have to look closely at the ambition of global regulators. Will they attempt to force an emission boundary on the map for zero-carbon fuels before the international fleet even has the engines built to cross it?
That is the million-dollar question, because drawing a red zone on a digital map is a matter of a few keystrokes. But engineering a massive vessel to survive the crossing without breaking apart the global supply chain, well, that's a completely different reality. Thank you for sharing these incredibly detailed sources with us and taking us into the real realities of the maritime world. Keep exploring, keep questioning, and we will see you on the next deep dive.